In this video, I am going to show you a couple examples of finding a vector, usually used described using the letter V, that is a linear combination of some other vectors. Alright, so let's take a look at what we have, and we will also look at a geometric interpretation of these operations. So the first step is make sure we can differentiate between them. So what I do is I use, there you go. Okay, these different colors here. We got purple, red, and blue to help us keep track of everything. So we are told the following facts. One of the vectors is u. Okay, and the components of this vector are the following: 2 and -1. Then we have another vector, and that is w, and the components of this vector are 1, 2. 1, 2. There we are. Okay, so red and purple, and then what we want to find are various combinations of these that produce V. Okay, so let's take this carefully. Okay. First step, set up a coordinate system and do all your work within the coordinate system. I don't want to use, we'll use this one here. I don't even know what color this is, but you know, it'll do its job. There we are. So we're setting up a little coordinate system. This is X and this is Y. Let's mark 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. -1, -2, -3, -4, -5, -6, and so on the left. Right? So this is our little coordinate system. And what we are told is the following. This is the vector u, which has components 2, -1. And there's the vector w, which has components 1, 2. So let's take a look. Let's first draw u. Okay? So u has an x component of +2, so that's 2 to the right, and then a y component of -1, so that's 1 down. So here is u, okay? This is the vector u. Let's mark vector w. It's got a y component of 2 and an x component of 1. So 1 to the right and 2 up. So it looks like this, okay? This is our vector here. So these are our two vectors, u and w, and now we're going to take a look at little pictures. I feel like Picasso here with all these colors, okay? To illustrate various linear combinations of these. Alright, so the first is this. Say you are asked to sketch a vector V that is 3/2 of u. Okay? So algebraically what we do is this. You take your 3/2 and you distribute it over the components of vector u, which gives 3/2 times 2, and then 3/2 times -1, which then turns into, the 2's cancel, and what we have is 3, and the 3/2 times -1 is -3/2. Okay, so this is 3/2 of vector u. So where do we draw this new vector? Well, Let's return and let's label things a little more clearly still, right? This was our U, and the purple one here was our W. Okay, so this is the following vector. This one here, 3/2 means 150% of. Okay, so it still lies along the same line as the red one, but it's bigger like this, okay? That's 3/2 of U. All right, let's take a look at another scalar multiple here, and the next one is V equals U plus W, okay? So we have, let me color code this, U plus W, okay? So let's carry out this operation algebraically first to see what we have. So the components of U are 2, -1, and to it we are adding W. So W, of course, is 1, 2. So the next step, we combine the x components and the y components. So we have the following: 2 from the red vector from U, and to it we will add the 1 from W. So it looks like this. Okay? At the next step, what we do is we take our -1 and we add to it that +2 from W. So it looks like this. The rest of it is simple arithmetic. So you have 2 plus 1, of course, which is 3. And then you've got -1 plus 2 positive, which is +1. So this is the vector that is the sum of U and W. 3, 1. Let's depict this vector in the plane. Because the common question in textbooks is, given two vectors, make sure you can draw them, and then perform some operations between them or on them using addition or subtraction, and then also be sure you can draw the resultant, okay, or what results from those operations in the plane. Okay, make sure you can draw a picture of that process, or the result of the process. So in this case we have 3, 1, so it looks like this: 3 to the right and 1 up. There we are. Okay, so this vector right here, okay, that I've just marked, that one is this new V. This is the one that is U plus W. Okay, that's U plus W right there. That vector. Okay, let's get an x component of 3 and a y component of 1. So you see that V is what we call a linear combination of these other two vectors. Let's take a look at another example, finding V. Another V. Okay, so V is now defined as follows. It's U plus 2 times W. Okay, so V this time is U plus 2 times W. So let's carry out the steps. The first step is make sure you know to distribute the 2 over the components of W. So let's write this out. U is given by 2, -1, so it looks like this. And to it you will add twice W. So W has components 1 and 2. Okay, so it looks like this. Okay, so you have 2, -1, and then 1 and 2 with a 2 on the outside, multiplying vector w. So first let's carry out a scalar multiplication. That's the first step. Okay, so let's do that right now. So first we have just 2 negative 1 plus, and now what we are doing is using a distributive property. So 2 times 1 is 2, and then 2 times 2 is 4. So it gives this. And at this point, this is just like the previous example, we just combine the x components and the y components together, getting a new vector. So let's do that. 2 plus 2 is 4, and negative 1 plus 4 is positive 3. So this is the vector 4, 3, and it's the result of taking u and adding to it double w. Okay, so u plus 2 times w. Let's draw a picture of this new vector in the same coordinate space here. Although it's getting a little crowded, here it might be helpful if you had several such grids to draw these vectors in each one individually. So the x component is 4, so you go over 4 to the right, and the y component is 3, so 3 up from there. 1, 2, 3. There we are. So this new arrow that I've drawn represents u plus 2 times w. Okay? This new arrow represents u plus 2 times w, which has the components 4, 3. So the key idea here is, notice, you're given u and w, and then you're operating on these, and you're producing new vectors, right? This first vector we made, right here, that's a vector. It's got components 3, negative 3 halves. This one we made is a new vector. This one we've just made from the linear combination, that's a new vector. So each of these is a new vector, right? And then what you want to do for extra insight is know how to depict these linear combinations in the plane, as I've done here. Okay? So the first one, let me label it, was actually this one here. That was 3 halves of u. Okay, there we are. So this first black arrow was 3 halves of u. This one here is u plus w. And this latest one is u plus 2w. So these are all examples of expressing or combining two vectors to produce a third vector. And that third vector then is described as a linear combination of the other two. So that's it for this one. Thank you for watching. And in the next video, I will do something similar, but focus more on negative numbers in the examples. So thank you for watching.